Everyone, thanks for joining us for the webinar today on protein with our special guest presenter, Dr. Brad Dieter. Just have a few things I want to say before we get started. So one, if you have questions throughout the presentation, please type them into the dialog box there. You also have some handouts that you can download from the presentation as well. So take a look at that. We are having a little bit of technical difficulties here. So if something happens, just bear with us. Worst case scenario, we can re-record the presentation and have it available at a later date. But there is a lot of people who signed up for this and attending, and sometimes I can slow down the feeds to this. One other thing I'd just like to mention is, we're very excited to have you guys attend these webinars, and this is something we plan on doing going forward. So if you have suggestions for what you'd like to see us do in future presentations, please let us know. Like I said, I'd like to introduce our special guest presenter, Dr. Brad Dieter. He has an amazing background, so I'm going to go through his credentials and also some of the projects that he's working on. So Brad is a trained exercise physiologist, a molecular biologist, and a biostatistician. He received his bachelor's from Washington State University and a master's of science in biomechanics at the University of Idaho. He completed his PhD also at the University of Idaho. He completed his postdoctoral fellowship in translational science at Providence Medical Research Center, Providence Sacred Heart Medical Center, and Children's Hospital, where he studied how metabolism and inflammation regulate molecular mechanisms, diseases, and was involved in discovering novel therapies for diabetic complications. Currently, Dr. Dieter is a Chief Scientific Officer at Eat to Perform, Chief Scientific Officer at Outplay Inc., and is active in the health technology and biotechnology. In addition, he's passionate about scientific outreach and educating the public through his role on scientific advisory boards and regular writing on health, nutrition, and supplementation. So we're going to go ahead and turn it over to Dr. Brad Dieter here and let him start the presentation.
Awesome. Well, thank you so much for having me on, Mike. I'm really excited to be able to talk to everybody today, and looking forward to doing some educating, and then hoping we have some great Q&A. All right, so let's can we go to the next slide and get started? Awesome. All right, so today we're going to be talking about protein metabolism and how to optimize for both muscle gain and for weight loss. And so here's kind of an agenda that we're going to go through. This is kind of high level. This will kind of just set the stage, so we can kind of break this into 3 chunks, and then we'll dive into each individual piece. So up first, we're going to give you a quick crash course on understanding protein, kind of its role in human physiology, and then just a very brief understanding of protein metabolism and what actually happens when you consume protein and where it goes. I think a lot of people don't really know, what happens when we do that. Then we're going to cover, how much you should consume to maximize muscle growth, and then we'll talk about how much protein you should consume for weight loss. So let's start with here a crash course on protein structure and function, and primarily we're going to start with just kind of an overall crash course on protein metabolism. So let's go to the next slide. And we'll go one more. Perfect. So this is just a very brief overview of exactly what happens when you actually, consume protein. So let's imagine, you are either drinking a protein shake, or you're eating a piece of steak or chicken or eggs that contain protein. No matter where it comes from, the same process of metabolism happens regardless of the source. So when you consume it, you have whole proteins in your mouth, which are these long strings of amino acids. It doesn't really matter where they come from. This is what happens when they enter your body. And there's not a whole lot of digestion of actual protein that occurs in your mouth. What happens is it starts to go down and enters the stomach, and that's where it starts to get broken into smaller pieces. And so then those pieces are broken down even further into actually individual amino acids. And then those amino acids are actually taken up into your body in your intestinal lining. So the way that you can kind of think about it is, think about think about it like a paragraph, right? So you start with a paragraph which is full of individual words and sentences, and then you can break that down into smaller pieces. And so you kind of break things down from a whole paragraph into sentences, and then sentences into words, and that's how you understand things from one word at a time. And that's kind of the way that protein metabolism works. So you start with the whole protein structure in your mouth, and it gets broken into smaller and smaller pieces until it's actually taken up into your body in your intestines. So it kind of goes through the full digestive process and then gets taken up. Let's go to the next slide. Perfect. So really the amino acid pool is the basis for protein metabolism. So all those individual amino acids that you take up into your body from your intestines really serve the whole purpose of protein. So it's not the full proteins that you eat in your food, but it's the actual individual amino acids that make up those proteins that provide your body with the amino acids the protein needs that your body needs. So it's kind of the way that we can think about it is you have this free amino acid pool of about 100 grams at any given time that are in just free form amino acids floating around your body. And that 100-gram amino acid pool is basically giving amino acids to your body to do things, and then when you consume protein dietarily, you're adding to that pool. So amino acids are always being taken out and they're always being put in. Now, a lot of people think that your dietary protein is one of the biggest sources to this amino acid pool through the day. And on average, you have about 100 to 150 grams for the average American of individual amino acids that go to this free amino acid pool. But your actual body protein, so proteins that come from your muscles or your bones or anywhere else, actually provide about 400 grams a day to this amino acid pool. So you're actually turning over amino acids quite extensively in your body at a rate of about 4 to 1 of what you consume. And so that's kind of why it's really important to understand, how important amino acids are to your body. So if you're turning over about 400 grams a day between breaking it down, building things, and then breaking it down and building things, what you get from your diet helps supplement that large amino acid pool that your body actually needs to pull from. And then those amino acids are used to build body proteins. They're used to make enzymes, and they're used for all the really important things that your body requires to function. Okay, next slide. Perfect. So here's exactly what happens when you consume protein, really regardless of where it's from, and how it kind of tracks and where you lose protein and where it actually ends up. So let's say you consume about 20 grams of milk-based protein. So let's say this is a 20-gram whey protein shake. So when you consume the 20 grams, about 50% of that, so about 10 grams of the 20, is actually kind of taken up by your stomach and your intestines and actually used in your stomach or your intestines for all the processes that it needs. So you lose about 50% of that protein before it actually enters your body. And then of that, 50%, another 40% is actually used right away, either to provide energy, to make neurotransmitters, or to kind of process, a specific compound in your body called urea. And then only about 10% of that total protein, so about 2 to 2.5 grams, is actually used to build new proteins, right? So let's say it's skeletal muscle tissue. Of that 20 grams, only about 2 actually makes it into your muscle tissue. So protein is used for a whole lot of things throughout the digestive process, and only about 10% makes it to the end process of kind of building muscle tissue. Okay, next slide. So a quick recap. So this is your recap on your crash course on protein metabolism. So dietary protein is broken down into amino acids, which are then absorbed from the GI tract into the bloodstream. Dietary protein and protein from your body that's already there contribute to the overall amino acid pool. And then about 50% of the dietary protein makes it into the bloodstream, but only 10% of that goes to new protein synthesis. The other 40% goes to all the other processes that your body immediately needs to use the protein or the amino acids for. All right, next slide. Okay, so now we kind of break the rest of this talk into how to think about protein for muscle gain versus weight loss. And there's a lot of overlap between the two of them, but how we start to think about them can be really different. And some of the operationalization of some of the guidelines we give will differ between the muscle gain and the weight loss. So let's start with the the muscle gain piece. So let's start there. So next slide. So one of the first things that we need to talk about when we talk about, protein consumption for muscle gain, and the most important thing really is your total daily protein intake. So the most important aspect of, dietary protein, how we think about it in terms of muscle gain, is the first thing you need to think about is how much are you getting on a given day. So next slide. So some research was done in the last 2 years where somebody took all of the studies that we've done in people where we've given them a wide variety of protein intake in a given day and tracked their change in free fat mass or skeletal muscle tissue, and looked at what is the optimal intake of dietary protein in grams per day to optimize this increase in lean mass. And really what they found is that from about 0.8 to 1.6 grams per kilogram per day, you see kind of a linear relationship. So the more protein that you eat, the more free fat mass or free skeletal muscle mass your body accrues. But after about 1.6, it kind of levels off, right? It's kind of a diminishing returns. So basically, what we start to see is the more you consume, the more free fat mass your body adds, which makes sense. But as we start to get to higher end intakes, we start to lose some of the efficiency. So next slide. And that when you start to get into really high intakes, so about 1.6 grams per kilogram is kind of the optimal level where you start to see a diminishing return. There doesn't really appear to be any additional benefit when we get above about 2.2 grams per kilogram. So this was a study where they took people and they gave them 2.2 grams per kilogram per day and had them engage in resistance training, or they gave them about 3.3 grams per kilogram per day. And what you'll notice on this top figure here in the blue and the red is that there was no difference between the two between a high protein diet and a very high protein diet. So the 2.2 grams per kilogram and the 3.3 grams per kilogram actually gave us identical increases in free fat mass. So there was no additional benefit going above 2.2 grams per kilogram. Okay, next slide. So when we kind of think about this, we kind of take all the research that we really know about total daily protein intake and really break it down into a simple idea. This is kind of graphically how we should think about whether we're prescribing it for ourselves or for our clients, is daily protein intake of about 1.6 grams per kilogram. It's kind of the optimal intake for muscle growth in terms of the most ROI, right? So the most bang for your buck in terms of protein. Now you can consume more than that, and up to about 2.2 grams, you may see small incremental benefits between 1.6 and 2.2 grams per kilogram. But above that, there really doesn't appear to be any additional benefit. So the kind of the most optimal intake in terms of best return on investment from daily protein intake is about 1.6 grams per kilogram per day, which translates to about 0.7 grams per pound. And then that upper end of 2.2 is about 1 gram per pound. So that's really the total daily protein intake should fall 1.6 to 2.2 grams per kilogram, or 0.7 to 1 grams per pound per day. So that's total daily protein intake. Okay, so let's go to the next slide. So now that we kind of have the idea of total daily protein intake, one of the other big things that people want to know is, how much protein should we consume post-workout to maximize muscle protein synthesis, right? So if we engage in resistance training and we know that the kind of post-workout window is important for recovery and for muscle growth, how much should we consume? What is the optimal amount? And then also, the second question to that is, how much should we space our protein out over a given day? So let's go to the next slide. So this is just a diagram of a study that was conducted by some scientists who specialize in protein intake and optimizing this acute muscle protein synthesis response, so kind of right after exercise. So this was basically a study where they took people and they had them engage in resistance exercise, and then they gave them 3 different dosages of post-workout protein intake. So they either had them consume 10 grams of protein every 90 minutes, so hour and a half, for about 10 hours after their training session, or they gave them 20 grams every 3 hours, or they gave them 40 grams every 6 hours. So kind of, basically they would either have, 2 big meals in the afternoon after they got done training, or they'd have, 4 smaller snacks, or they would basically have, about 8 really small doses of protein. So this was kind of a good way to see, is it better to get your protein spread out throughout the day evenly, or in big chunks? And that was the point of this study, was to ask that question. So next slide. So really what they found was that, we'll kind of orient you to the top slide first. And these are just measures of, how much muscle is being laid down on top of your current skeletal muscle, right? So how much muscle is your body building right after the workout, depending on how much protein you consume. And so the gray bars is kind of the intermediate one. So the, about 20 grams every 4 hours or so. The bolus, what the black bars were basically the 2 big meals, and then the white was, every hour and a half they gave them 10 grams. And basically what they were able to show is that from right after exercise until about 12 hours, the 20 grams every 4 hours was better than the other 2. And that when you added them all up at the very end, the total 12-hour kind of muscle growth period, the intermediate, or the kind of 20 grams every couple hours, was the best approach to maximize muscle protein synthesis. So next slide. Okay, so here was another study. So now that we kind of have the idea of, it's probably best to kind of spread your protein out, every about 4 hours or so, in kind of moderate doses. Now the question is, how much should I consume right after? Is 20 better or is 40 better? So here was a study that kind of did the same thing as the last one. They brought people in, they had them engage in resistance training, and then they gave them either a 20-gram protein shake or a 40-gram protein shake, and they took a muscle biopsy and they actually measured how much muscle were they adding in the recovery process of from training. So we'll go to the next slide and we'll show you those results. So basically what they found was that when you gave people 40 grams of protein, they had a little bit better response than 20 grams. It wasn't double the response. It was about 10 to 15% better response at 40 grams than it was at 20 grams. So kind of the takeaway here is post-workout, 20 grams of protein gives you about 80 to 90% of the maximal, muscle protein synthesis response. And if you double that dose to 40, you get an extra maybe 10 to 15% of kind of post-workout muscle protein synthesis recovery. So a little bit more is a little bit better, and twice as much is not necessarily twice as good in terms of muscle protein synthesis or acute recovery and growth of muscle tissue. All right, we'll go to the next slide. So just like we saw the graph for the total daily protein intake, the same concept applies to our post-workout protein intake. So at about 40 grams post-workout is where we kind of get the optimal intake in terms of return on investment. So if you go from 40 to 60 or 40 to 80, you're not going to get double the response. You might get 5% better. And on the other side of the equation, if you have a client or yourself, 40 grams seems like way too much for you, or your total daily calorie intake doesn't allow you to have 40 grams post-workout. If you get 20, you're getting about 85 to 90% of the total efficacy as you are of getting kind of this optimal amount. So it's really good to remember that even if you're getting half, you're still getting most of the benefit. Okay, so next slide. So let's recap here. We'll just recap this section before we move on to the next one. So studies that have looked at high protein intakes show no measurable benefit on muscle growth above 2.2, so about 1 gram per pound, indicating a ceiling on growth, and that this is supported by meta-analyses, which is looking at dozens of studies together. Now, the true ceiling of what is really optimal, maybe closer to 1.6 grams per kilogram or about 0.7 grams per pound. But there's kind of, a little bit of ambiguity in that window. We don't know exactly what's perfect, and there's probably a big individual response. So that window of about 0.7 grams to 1 gram per pound is a really good window for a lot of people to fall in. And then the last one is 40 grams post-workout is most likely the best bang for your buck for most grown adults. However, 20 grams post-workout, within about 2 to 3 hours, you have a pretty big window. Still gets you most of that benefit, right? We're talking 80 to 90% of that benefit. All right, we'll go to the next slide.
Brad, we have a question for you. So one thing that we hear a lot of times is, how does total calorie intake or carbohydrate intake also affect this equation? So for instance, if someone's eating maintenance calories, right, and they're getting this optimal protein, what type of effect does that have versus if maybe they're eating, again, maintenance calories, but now their protein intake is very high and they're combining that with exercise? Does that change some of the recommendations based on that, in the sense of maybe carbohydrates sparing the use of proteins as an energy source?
Yes, so that's one of the really good questions, right? Is if you have a limited amount of calories per day, and you start consuming, let's say 50 to 60% of your total calories as protein, your body is going to use a lot of that protein for just energy costs, right? So it's going to try to make glucose and ATP out of those proteins. So, a lot of times if we have people, on a very low calorie approach, their protein intake may be a little bit higher because some of that protein is being used, and we'll talk about that in the weight loss piece. But on the other side, if somebody is at maintenance, one of the big issues that we run into, especially with people who have high training loads or athletes, if you're at a maintenance level and you start consuming, kind of at the higher end of the 2.2 grams per kilogram, and you're not getting a lot of additional recovery or muscle growth benefit, and you're using too many of your daily calories and not getting enough carbohydrates, you're not being very efficient, and you're not using the type of nutrients you need for your specific application. So if you're in a maintenance period and maximal muscle growth is not part of your program per se, getting closer to the lower end, 0.7 grams per pound or 1.6 grams per kilogram, and allowing for more calories to come from more usable energy sources like carbohydrates, that's where those people should fall. Did that answer the question?
No, that was great, Brad. Thank you.
Okay, perfect. Awesome. So we'll move on to the next piece, and we'll kind of address a little bit of part of that question. So now, one of the big other aspects of protein metabolism is, how does protein impact weight loss? So protein from a muscle gain standpoint is relatively straightforward. We need a certain amount to optimize muscle growth, and we can think about that in the terms of a calorie surplus. But on the other side of the equation is, how does protein impact weight loss? And there's a lot of really important aspects to consider. So we're going to kind of hammer home those big picture ideas. So we'll dive into the next slide. So one of the biggest things is that dietary protein itself can actually lead to eating less. So one of the big interventions that a lot of people will do whenever somebody goes on, sort of a diet, so to speak, is most approaches increase protein intake, right? So if somebody's eating a low to moderate protein diet, they will increase the percentage of their calories that come from dietary protein. And one of the reasons being is that it leads to spontaneous calorie restriction by themselves. So this was a study where they had people who, were basically eating a normal isocaloric diet. They were kind of in a energy balance state, so to speak, and then they increased their protein intake to 30%, and it actually led to, about a 500 calorie per day just calorie deficit. So they just started eating about 500 calories a day less, and that actually led to fairly substantial weight loss. So you can see here there's a really big drop off in calorie intake, and then their weight, they dropped it was about 6 kilograms, so about 12 pounds over the span of about 3 months, just because they started consuming more protein. So now, why might that occur? So let's go to the next slide. So the reason that dietary protein intake, so if you have, let's say, 2,000 calories and you're eating 15% of those from protein and you increase it to 30, why do people then start eating less calories is protein increases fullness, and it increases fullness throughout the day. So there's been a lot of studies where they've taken people and put them on kind of moderate protein diets or high protein diets and tracked their food intake and also just their feelings of hunger and satiety and fullness throughout the day. And what they show is that in every study that we've done as a scientific community, high protein intakes increase people's feelings of satiety. So they don't feel as full, and they actually reduce their overall calorie intake. And it's primarily due to kind of satiety and controlling hunger mechanisms. So this is why higher protein intakes, kind of that 0.7 to 1 gram per pound, helps people control total daily calorie intake, just primarily through increasing satiety and reducing hunger. So we'll go to the next slide. Awesome. So another really important aspect of dietary protein and weight loss kind of ties into the first topic of muscle growth. So one of the big things that we know that occurs with weight loss, and the more substantial weight loss you have, so the larger amount of weight people lose, the more likely they are to lose skeletal muscle mass. And that's something that we want to minimize as much as possible for two main reasons. One, we know from a metabolic perspective, kind of skeletal muscle is the biggest glucose sink and the biggest driver of human metabolism in our body. So your brain is really big. It consumes about 20% of your total daily calories. But also your skeletal muscle is one of the biggest metabolic sinks and kind of helps regulate overall metabolism. So we want to spare as much muscle tissue during weight loss periods. So there's a few things that affect muscle balance. It's muscle synthesis, so how much are you making? And those can be increased through resistance training, so lifting weights, or just consuming dietary protein alone. And muscle breakdown is increased when you're inactive or you're in a large calorie deficit, which is what happens, or what is required for weight loss. And then things that prevent muscle breakdown are insulin, the hormone insulin, or dietary protein inhibits muscle breakdown. So we can think about protein as both increasing muscle protein synthesis and decreasing muscle breakdown, which are two important pieces during weight loss. So we'll go to the next slide, and we'll kind of show you what this looks like in people. So this was a study where they basically took 40 men and they randomized them to kind of a low protein diet, which was about 1.2 grams per kilogram, or about half a gram per pound of body weight, to 2.4 grams per kilogram, which is about 1.1 grams per pound, so a little bit on the higher end. And then they put them in a 40% calorie deficit, which is a very large aggressive calorie deficit. Typically outside of research settings, we don't really use something that aggressive for most people. But they also had them engage in 6 days a week of exercise. And then they tracked them, and then they measured changes in body weight and body composition. And we'll go to the next slide and see what happened. So the darker green bars are the high protein group, and the lighter green bars are the low protein group. And basically what they were able to show is that both groups lost about the same amount of weight. So they both lost just a little under 4 kilograms, so a little under 9 pounds. And the important difference is that where that weight loss came from was different between the groups. So the group on the high protein diet, they actually saw an increase in lean body mass. So between their skeletal muscle and their actual skeleton bone structure, they saw an increase of about 1.5 pounds, or about 2 pounds, of total lean body mass. And they actually saw greater fat mass reduction than the low protein group. So when you take people and you put them on a calorie deficit, if you increase their dietary protein, you spare muscle tissue. In some cases, you can increase lean muscle mass, and you increase the amount of weight loss that comes from body fat. So you can kind of use protein as a lever to kind of change body composition and where weight loss comes from when people are, in calorie deficits and going after weight loss. So we'll go to the next slide. And then this slide is a little bit blurry. Looks like the resolution is a little bit low, but basically this is just a accumulation of about 4 studies that have done the same thing. And they've tracked people for short periods, 2 weeks, all the way up to 4 months. And in all these studies where they gave people, regardless of whether they were overweight, they were normal weight people, or they were considered obese people, and regardless of the duration, high protein diets increased the amount of lean muscle tissue that was on these people when they lost weight, and increased the amount of fat mass these people lost. So in not only one study, but in almost every study we've conducted, higher dietary protein intake improves body composition changes during periods of either moderate to even aggressive caloric restriction. We'll go to the next slide. So here's a recap. So higher protein intakes of right around 1 gram per pound can cause people to eat less calories overall, in part by increasing their feelings of fullness, and that this itself can lead to extra weight loss. Higher protein intakes of right around 1 gram per pound can also help people maintain muscle mass, and in some cases slightly increase muscle mass during periods of calorie deficits or dieting periods. So next slide. So here's how we can apply this in terms of weight loss situations. So setting protein intake higher at about 1 gram per pound can help suppress appetite and maintain lean muscle mass during deficit cycles. Now, there's less emphasis on protein timing when total daily protein intake should be the focus. So when we think about muscle growth, the timing and how you spread protein out throughout the day is a little more important than when you have kind of a weight loss or dieting cycle. So you have to worry less about the timing and more about is somebody just getting it in a given day. And then the last piece is protein alone during weight loss can only do so much. You need some sort of stimulus to tell your body to hold on to muscle tissue. So resistance training is critical during periods of dieting and should be coupled with higher protein intakes. All right, and I think that is the last slide. And we thank you guys for your time and attention, and looking forward to any questions you guys have.
Thank you, Brad. That was great. We're getting some questions in, so we're going to do a little Q&A here. And one popular one we're getting is how does protein intake differ for men and women, if there is any difference between the two?
So protein intake, from what we know from the literature, doesn't seem to be different between men and women in terms of need. Largely because protein intake really should be based on body weight and lean body mass. And while men and women have different, relative percentages in terms of just, the way that we have biological differences, the absolute needs don't tend to differ between men and women. Now, there may be some cases, especially during kind of the menopausal period in women's lives, where their protein intake might be a little bit different than men at that same age. But there doesn't appear to be any substantial difference even then. It's just women probably should be a little more cognizant of having higher protein intake than men during that period, mostly because of how protein affects bone metabolism.
Great. And then another question with senior population. So with someone who's older, does their protein ability to absorb protein decrease as someone ages? And in that case, does that mean that they need more protein relative to a younger person?
Yeah, so that's been a more hot topic probably in the last 5 to 6 years, and we're really just starting to get a better understanding of that. And so what I know from that research so far is elderly people need to make sure they're on the higher end of things. Do they need, more than about 1 gram per pound? I don't think there's any research to indicate that above that threshold starts to give a lot of benefits. Whereas, the younger people can sustain themselves in do pretty well at, kind of the lower 0.7 gram per pound. Elderly people definitely tend to do better based on the literature at that higher end of about a gram per pound. And that comes down to, their ability to digest protein, and just all, food in general is a little bit lower. They get less physical stimulus, so the protein needs actually kind of help give you a more anabolic signal than people who are younger and more active.
Great. And then you mentioned this earlier, though, for the elderly populations, you still would need that, or at least an important component would be the stimulus of resistance training along with the protein to maintain muscle mass as someone ages.
Mm-hmm. Yeah, and that's one of the, the two of the biggest things for elderly people and their quality of life as they age is, bone density and muscle mass, right? So interestingly, one of the biggest predictors of quality of life as people age is kind of their hand grip strength. And so that just comes down to, that's just a proxy for overall, muscle mass and strength. And so having those people focus on maintaining muscle mass and maintaining bone density is really key. And really the only way to prevent decline in those as you age is to stay physically active and kind of make those a priority. So you have to do some loading, you have to do some sort of resistance training, and making that a big focus of what people do.
Great. All right, so another question we're getting, it's more about the specific form of proteins, so is whey protein the best form of protein? Is it a casein? Is it a combination of proteins? Or do we not know what the best form is?
So there's kind of a few ways to think about it. And I try to think about these things as pragmatically as possible. So the first differentiation is between animal protein and plant protein. We do know that animal-based proteins have a complete amino acid profile, and those are better than plant proteins, kind of, gram for gram. So, kind of the rule of thumb is plant proteins give you anywhere from 60 to 80% of the biological value of an animal-based protein. So that's probably the first distinction. And then from there, within each category, there doesn't appear to be a large difference. So in the animal-based protein, whether it's from chicken or fish or whey protein specifically or casein, the differences between those and kind of overall anabolic signal is very small. It's 5 to 10% at most difference, and that doesn't, for most people, you'll never see that difference manifest out. So the first thing is, understanding if you are getting all your protein from plant-based sources, you probably need a little bit more than somebody who's getting it all from animal-based. But then within those, there's not a huge difference. None of the work that I've ever done have I gotten to the point where I've gotten clients like, hey, you have to take this specific form of protein versus the other because there's anything that suggests that it's a meaningful difference.
Great. Another question here that comes up a lot with protein or higher protein intakes is, the effect of protein on bone in the body, and then also maybe, is it affecting our kidneys or other organs in the body when we have high intake? So what does the latest research say on those topics?
Yeah, so I'll start with the bone one first. So that's been studied really extensively, and there's one guy by the last name of Kerstetter who's done all the work in that area. And between about the mid 90s to now, he's done probably 15 or 20 studies that have looked at that. And all of them show that higher protein intakes actually lead to a net gain of bone density. So some of the early literature suggesting protein causes some, acidic environments and causes kind of leaching calcium from the bones was based on some very acute studies that just looked at acid-base balance and didn't really think about the whole body in general. And so since then, all the research has come out that shows higher protein intakes actually improve bone density, especially in older people. So the studies in women, postmenopausal women, especially who suffer from osteoporosis the most, higher protein intakes actually prevent or reduce the risk of osteoporosis. So it's actually the opposite of what we typically hear. And then the kidneys. So, you know, I did my fellowship in nephrology, so we spent a lot of time thinking about protein in the kidney. And there's a few things. So one is, in otherwise healthy people who have no kidney issues, there's no detriment to higher protein intakes that we've seen, right? So the research has shown up to, you know, about 2 grams per pound, which is a really absurdly high intake. There's no long-term detriment on your kidneys that we've seen in people with otherwise healthy kidneys. On the flip side, people who have established chronic kidney disease, whether it's, you know, from, you know, chronic kidney disease from diabetes, whether they've had a kidney transplant due to some acute injury, but anybody that has compromised kidneys already, that's where lower protein intake is really a necessity. So if you do have a pre-existing kidney condition, most of the literature, you know, finds about 0.6 to 0.8 grams per kilogram, so kind of a lower protein intake. You know, that's about 0.4 to 0.5 grams per pound is where people with established kidney disease should be set. You can get higher intakes if your disease is very mild, but as your disease progresses, you need the lower protein intake.
Great. And then go 2 more questions here, Brad. So one here is, and you've kind of mentioned a little bit of this, but with regards to like gaining muscle mass, recommended time window to consume protein after working out. So I know that there were some changes where at one point it was like, hey, you got to take in protein right after working out, or else you're kind of wasting that workout, to where there's been some other research showing that window is a little bit longer. But really, what's the optimal window, right? So regardless of time and stuff, is it better to eat, you know, closer to the workout if your goal is to maintain that or to gain muscle mass, or does it not matter that much if you wait 30 minutes versus 2 hours or 4 hours afterwards?
Yeah, so what I would say is, my interpretation of the literature so far is that window is fairly wide. You know, 2 hours is about kind of where things start to get a little murky. We don't know, like, is 2 to 3 hours, is there any fall off? But what we do know is there's absolutely no detriment to getting your protein intake, you know, between 15 minutes and 2 hours post-workout. There may be a small benefit that we just can't see, but my thoughts are, the closer you get it to your workout, the better. You know, I would try to tell people, if you can get it within, you know, within 2 hours, closer to a half an hour afterwards, that's probably your best bet. You know, the longer you get away from it, the less likely you are to optimize everything. I would say it matters a lot more for people who are, you know, training twice a day, or people who train right before they go to bed. Make sure you don't go to bed without getting something. So that would be my advice, is, you know, the closer to your workout, the better. There's no detriment from it, and if there is any benefit, you're going to get that benefit.
Mm-hmm. Makes sense. And then last question. So we talked a little bit about carbs and protein, but if someone's on a keto diet where their percentages of fats are very high, does that affect some of these numbers that we talked about with protein intake if someone's on a ketogenic diet?
Yeah, so typically people who go on a ketogenic diet use it for weight loss. And so, you know, understanding whether somebody's using it for weight loss versus trying to add muscle tissue, the conversation changes a lot. So if it's in weight loss, you know, that 1 gram per kilogram, or 1 gram per pound, excuse me, is still kind of the window you want to aim for. Now you can eat more if you want, you know, to hit your total calories and for satiety, and, you know, the fact that you don't have any other options, right? If you can only consume protein or fats, you kind of have to choose one or the other. So as long as you're hitting that 1 gram per pound, you know, in a ketogenic diet for weight loss, you're probably getting the maximal benefit. For the muscle growth side, there hasn't been any specific studies that have looked at, you know, muscle growth over a long period of time in a calorie surplus on a ketogenic state. But one of the things we do know about muscle protein synthesis and training volume and hypertrophy is protein and carbohydrates together give you the largest anabolic signal. So if you remove carbohydrates, you blunt that post-workout, maximal anabolic signal. 2, we know that training volume and intensity are the 2 biggest things that drive muscle growth. And removing carbohydrates from your diet limits both of those. And then, overall recovery capacity in terms of higher intensity training is limited on a lower carbohydrate diet. So there's kind of the 2 sides to that coin.
Got it. And then is there any concern with the ketogenic diet if the protein intake is too high, where the body might, through gluconeogenesis, convert that protein to an energy source, therefore kicking someone out of ketosis if someone is trying to maintain that ketogenic diet?
Yeah, so I was actually involved in a project that looked at that question, because that's been kind of talked about a lot. Everybody talks about you can't eat a certain amount or you're going to kick yourself out of ketosis. And all of the actual hard data on that is very circumspect. Like, there's no solid answer that we have of how much can you eat before it kicks you out of, a ketogenic state. So what I would say is, 1, if you're going after a ketogenic diet, kind of understand that the actual ketone levels in your blood don't mean a whole lot for like weight loss, right? So there's no correlation between higher ketone levels in the blood and weight loss. So if you're kind of like trying to optimize those levels and sacrificing protein intake for that, I'd say, hit the protein intake and kind of spare your muscle tissue as much as possible. And then the second would be, I wouldn't worry too much about, the small amount of blood glucose that's being, or the amount of glucose that's being made from the amino acids you're consuming. It's not a huge concern. And there's no real signal that we know of, like, if you're consuming 1.5 grams per pound, you're, never in a ketogenic state due to gluconeogenesis. So that would be my response. Is there's no clear indication of what that level is, or even if, higher protein intakes are harmful or not harmful, but, detrimental to ketosis itself.
Awesome. Well, that was all of our questions for now. So want to thank you for the presentation, phenomenal information. If someone wants to find you out there, Brad, where's a place that they could reach you or contact you?
Yeah, you can find all of our work at eattoperform.com. That's kind of where we have built a nutrition coaching company and some software, and kind of our platform lives. And then people can just find me. I'm on Facebook or Instagram or any of those places. They can find me. If anybody has questions, feel free to reach out. Always available and happy to answer anybody's questions that they have.
Yeah, and we'll be announcing some stuff in the near future too, of a big project that we're working on with Dr. Brad Dieter, and so I'll have more details about that next month. But again, I want to thank you for all the information today. If you guys do have questions out there still, feel free to filter it into us and we can pass that on to Dr. Dieter here and get back to you with that information. But thank you.
Awesome. Thank you very much.